Hi, coming to problems that we were discussing, like whenever the number of observations are increased, then the accuracy of the instrument increases because we have the formula A mean means average value of the all overall readings. How to take average value is equal to A mean is equal to A1 plus A2 plus A3 and so on till AN by number of readings, how many number of readings you have taken. So this is the formula. So it is more accurate, 100 readings is more accurate than the 5 readings. Coming to next question. The photograph of a house occupies an area of 1.75 centimeter square. Area of photograph of a house 1.75 centimeter square on a 35 millimeter slide. The slide is projected onto a screen and the area of the house on the screen is 1.55 meters square. What is the linear magnification of the projector screen arrangement? If you observe the problem here, area of house of photograph is 1.75 centimeter square. See here, centimeter square on a 35 millimeter slide. House of the screen 1.55 meter square. Centimeter, millimeter and meter square means you must know how to convert from millimeter to centimeter, centimeter to meter square. So units, whenever you are solving the problem, all readings, whatever the given data is there, if they are in different units, you must convert for a same unit. Either you have to make it for meter, you have to convert this value for meter and this value for meter and this value already is in meter, or else if it is in centimeter, then you have to convert for this is in centimeter and this is also in centimeter, then only we can solve the problem. So unit must be same while taking the readings, given readings on the formula. Now see here, area of the photograph given data 1.75 centimeter square, write it. Then this one, area of the house on the screen is 1.55 meter square. This is in centimeter square, we must convert for centimeter square. So 1 centimeter is equal to 1 by 100 meter, or 1 meter is equal to 100 centimeter. So here into 10 to the power of 2 whole square I have to write to convert for centimeter square. 10 to the power of 2 whole square is 10 power 4. So 1.55 into 10 power 4 centimeter square. Now we have the formula for magnification to find out the area. So magnification in area of photograph is equal to area on the screen by area of the house in photograph. So this area on the screen is 1.55 into 10 to the power of 4 and area of the house in photograph is 1.75. If you divide these two values, you'll get 8.857 into 10 power 3. Then this is the magnification value, right? So linear magnification value, if you want to find out, then linear magnification, because in the question they mentioned what is the linear magnification. So then linear magnification is equal to under the root of aerial magnification. So root 8.857 into 10 power 3. If you do, you'll get 94.1. There is no unit for this because for magnification there is no unit. Next, state the number of significant figures in the following. See here, while solving this type of question, you must know rules for significant figures. If you are thorough in rules of significant figures, then you can go for this. Now here, first question, 0.007 meter square. How many significant figures are there? Only one significant figure, because zeros here, non-zeros are there, non digits are there, non-zero digits are there here. So how many non-zero digits are there here? Only one. But after decimal, before decimal, what is the number here? 0. After the decimal also 0, 0. So we need not to count this. So only non-zero digit is how much? 1. So significant figure is 1 here. Coming to next one, 2.64 into 10 power 4 kg. Here no need to take this 10 power 4. You have to count 2.64. How many? 1, 2, 3. 3. So significant figures are 3. Next, 0.2370. Here how many significant figures are there? 0. You need not to count. 2370 you have to take. So here it is 4 significant figures. 6.320 joules. That is 4 significant figures. 6.0332 Newton per meter square. How many significant figures are there? 4. Right? 0.006032 meter square. No need to count this 0.000. So 6032 you have to consider. So 4 significant figures. So how I have taken this, how I have mentioned these significant figures. So before solving this type of questions, just remember rules for significant figures, which we have already discussed while doing the theory topic. Next question. The length, breadth and thickness of a rectangular sheet of metal are 4.234 meter, 1.005 meter and 2.01 centimeter respectively. Come here, 4.234 meter, 1.005 meter, but here 2.01 centimeter. See here, units are changed, meter, meter. Okay, this is L, this is B, length, breadth, and this is height. Thickness. This thickness is given in centimeter, but you have to convert for meter. So here, area, how to find out? Give the area and volume of the sheet. So area is equal to what? Length into breadth. Length into breadth. So length is given, breadth is given. Just multiply, because this is in meter, this is in meter. Just multiply these two. 4.234 into 1.005 into 2. Because this is a rectangular, right? So twice you have to do. So 8.51034 you'll get. If you round off this number, 8.5 meter square. Coming to volume, volume is equal to length into breadth into height, or length into breadth into thickness here. So 2.01 is given, you must convert for meter. So into 10 to the power of minus 2. So multiply this 4.234 into 1.005 into 2.01 into 10 to the power of minus 2. Multiply everything. These 3, L into B into T, or L into B into H value. T value becomes H here. So multiply here 8.55289 into 10 power minus 2 will get. So this is 0.01. Multiply these two, will get 0.0855 meter cube, because volume SI unit is meter cube. Area SI unit is meter square. Right? Next question. The mass of a box measured by a Grosser balance is 2.3 kg. Mass of the box is 2.3 kg. Two gold pieces of masses 20.15 gram and 20.17 gram are added to the box. Already box is there of mass 2.3 kg. Two gold pieces added for that. How much? 20.15 gram, and afterwards 20.17 gram is added to the box. What is the total mass of the box? The difference in the masses of the pieces to correct significant figures. So first here, total mass. Total mass means what I need to do? I need to consider this mass of the box. In addition to that, gold pieces masses M1 and this is M2. Two different masses. Just Add these all this. Total mass means this 2.3 kg, 20.15 gram plus 20.17 gram. See here, this is in kg, this is in grams. So you have to take in this way. You have to convert for kg into 10 to the power of minus 3 into 10 to the power of minus 3, or you will get 0.0217, and this is 0.0215. So total mass is how much? 2.3 plus 0.0217 plus 0.0215 kg. Converted these grams for kg, right? Then you'll get 2.3442 kg. Next B question is the difference in the masses. So here no need to convert, just see here which is higher value, 20.17, here 20.15. This is in gram, even this is also in gram. Just difference of these two, 20.17 minus 20.15, you'll get 0.02 grams. Here difference of mass is 20.17 minus 20.15 is equal to 0.02 gram, right? Then since how many significant figures are there in this? There are two significant figures. So the difference in masses to the correct significant figure is 0.02 grams. Next question. A physical quantity P is related to four observables A, B, C, D as follows. They have given P equation. P equal to A power cube B square divided by under the root of CD. So while doing relative error, absolute error, this kind of problem we solved, right? So now the percentage errors of measurement in ABCD are 1%, 3%, 4% and 2% respectively. So A is related to 1%, B is related to 3%, C is related to 4% and D is related to 2% respectively. What is the percentage error in the quantity of P? If the value of P is calculated using the above relations, turn out to be 3.763. If you do so using this relation, if you apply these percentages, you'll get 3.763. To what value should you round off the result? So here P is equal to A cube B square by root CD. This is the equation. Now delta percentage error formula, do you remember? That is delta P by P is equal to delta A by A. But here cube comes, constant comes beside of the value. So 3 delta A by A plus here B square is there. 2 into delta B by B plus root of CD is there. Root means 1 by 2. So 1 by 2 delta C by C plus again root of CD, right? Even root applies for D also. So 1 by 2. Only this is root C into D. So root applies only for a C. This is only D term it is. So delta D by D. Here delta A by A 1 by 100, delta B by B 3 by 100, delta C by C 4 by 100, delta D by D 2 by 100 according to the given values. Now delta P by P is equal to 3 into 1 by 100 plus 2 into 3 by 100 plus 1 by 2 into 4 by 100 plus 2 by 100. So now percentage error is P is equal to, here I'll get 3%, here you'll get 6, 2 1s 250. So if you divide this value, I'll get 6%, right? Plus here we'll get 2% and here we'll get 2%. So total 3, 6 plus 2 plus 2, 13% you'll get. Next, a book with many printing errors contains 4 different formulas for the displacement y of a particle undergoing a certain periodic motion. See here, there are 4 equations are given. So according to dimensional formula, you have to verify whether this given equation is right or wrong. So y is equal to a sine 2 pi t by t. Here, coming to this sine 2 pi t by t. It's a constant term, right? 2 pi t by t. Sine of this function is constant. So if it is constant, it is a dimensionless. M power is 0, L power is 0, T power is 0. Then y is equal to a. Then this equation is correct. Coming to this equation, y is equal to a sine vt. Vt is not a dimensionless quantity because velocity is having some dimension, time is also having some dimensions. Then it is wrong. Coming to this, y is equal to a by t sine t by a. T by a is not dimensionless because t is having unit, second a is having some unit, meter per second square. So this is not a dimensionless, so it is a wrong. Next, coming to d, y is equal to a root 2 sine 2 pi t by t plus cos 2 pi t by t. Yes, 2 pi t by t is a dimensionless because 2 pi is a constant, t by t. Here second also second gets cancelled. So it is a dimensionless quantity. So it is correct. So first one and the last one is correct, but the B and C are not dimensionally correct. So hence they are wrong. Next, here. A famous relation in physics relates moving mass m to the rest mass m naught of a particle in terms of its speed v and the speed of light c. This relation first arose as a consequence of special theory of relativity due to Albert Einstein. A boy recalls the relation almost correctly but forgets where to put the constant c. He writes m is equal to m naught by 1 minus v square power 1 by 2. Guess where to put the missing c. See here, equation, a famous equation it is, E is equal to mc square. Based on that, so when the body is in rest and the body is in motion, when the body is in rest, mass has taken as m naught, and when the body is in motion, Einstein has assumed it is as m. See, while relating this theory of relativity, so different masses when the object is in rest, it has different mass, but when the object is in motion, it has different mass, slight difference in the masses. So only he assumed rest mass is m naught and moving mass is m. Here he recalls a boy, a student relates the same theory, but he forgets to write where to write this c. Then we have to adjust that c, where to write. So now observe this equation, m is equal to m naught by 1 minus c root 1 minus v square by 1 by 2, right? So m by m naught, take it one side because m and m should come one side, right? So I'll take m by m naught one side. I'll take this m naught this side, m divided by m naught. Then what happens is equal to what happens, 1 minus v square 1 by 2 remains here. 1 by 2 means what? Root of 1 minus v square. So here on rearranging, what happens, m naught one side, this m comes this side such that it goes this side. So m naught by m here is equal to root of 1 minus v square. Since the left hand side is dimensionless, see here m is in kg, m is also in kg. Rest mass unit is kg, moving mass unit is kg. Kg gets cancelled. This is dimensionless here. m0 dimensionless here. So this should be like that, right? So root of 1 minus v square divided by c square. Are you getting? Divided by c square. If you do so, he'll get here v square is there. V square is meter per second whole square. C is a unit. Speed of light is also meter per second. Right. Divided by c square I have to write here. So the equation becomes 1 root of 1 minus v square by c square. In this way I have to write, because here meter per second square, here also meter per second square. This is meter per second, this is meter per second. Square will be there. Here also v square is there, here also c square is there. So then upper unit and lower unit both gets cancelled, right? So I have to mention, I have to rearrange this 1 minus v square under the root as root 1 minus v square by c square. Next question. The unit of length convenient on the atomic scale is known as angstrom. Angstrom, 1 angstrom is equal to 10 to the power of minus 10 meter and is denoted by angstrom. 1 angstrom is equal to 10 to the power of minus 10 meter. The size of a hydrogen atom is about 0.5 angstrom, means 0.5 into 10 to the power of minus 10 meter in terms of meter. What is the total atomic volume in meter cube? See here, in meter cube you have to convert of a mole of a hydrogen atom. Now, volume of the hydrogen atom. What is the formula for volume of a hydrogen atom? 4 by 3 pi r cube. Coming to here, 4 by 3 is a constant. Pi is also constant, 22 by 7 or 3.14 r cube. So here r value is given here. What is that? Size of the hydrogen atom is 0.5 angstrom. So 0.5 into 10 to the power of 10 meter cube. So just multiply these three values. You'll get 5.23 into 10 to the power of minus 31 meter cube will get, right? Here, according to Avogadro number hypothesis, 1 mole is equal to how much? According to Avogadro's hypothesis, 6.023 into 10 to the power of 23 atoms. Right, 1 mole of hydrogen contains 6.023 into 10 to the power of 23 atoms. That is Avogadro's hypothesis. So now here this value must be multiplied with this Avogadro number. 5.23 into 10 to the power of minus 31 meter cube into 6.023 into 10 to the power of 23. If you do this equation, if this becomes 3.15 into 10 to the power of minus 7 meter cube. See here why they have mentioned 10 to the power of minus 3. Very simple. First you have to multiply 6.023 into 5.23. You'll get us 3.15. Here 10 power minus 31 and here 10 to the power of plus 23. Plus 23 minus 31. How much? Minus 31 plus 23 means how much you'll get? 8 you'll get. So minus 8 you'll get. So 1 point is shifted. If you 31.5, 1 point is shifted here. So 3.15 into 10 to the power of minus 7 meter cube. In the next class we will continue.